Okay, so we're making good progress with understanding these limits, the type 3 kind. Let's do, let's boost up the difficulty just a little bit, and we'll see that we'll look at some that are a little bit harder. How about this one? The limit as x goes to 4 from the right of 3x over x plus 4. Let's, sorry, x minus 4. And we'll do the other side as well. The limit as x goes to 4 from the left of 3x over x minus 4. How about those two? Well, here the number that, the first one, if x is going to 4 from the right hand side, then x is a number maybe like 4.01, say. Okay? And, well, I'm sorry, first of all I should verify that it's type 3, right? So when this limit's presented to me, the first thing I do is I put 4 into the top and to the bottom. When I put 4 into the top, I get 12, and the bottom I get 0. So it's 12 over 0. So it's not 0 over 0. So we know we're in type 3. Now, if x is going to 4 from the right-hand side, x is maybe a number like, I don't know, 4.01 or something. 4.01 subtract 4, that's a small positive number, right? So the top is like a number close to 12, and the bottom number is a number that's a small positive number. And 12 divided by a small positive number is a big positive number. So this answer is plus infinity. What about over here? If I'm approaching x from the left-hand side, then the kind of value that x is would maybe be something like 3.99. 3.99 minus 4, that's a small negative number, right? So the top is still a number that's close to 12. 3 times 3.99 or whatever, that's close to 12. So the top is close to 12 and the bottom is a small negative number. And 12 divided by a small negative number, that's a big negative number. So this answer is minus infinity. So that's how you do those kind. Let's just let's keep going. How about something like this maybe? The limit as x goes to, well, let's use a different letter. How about t? The limit as t goes to 3 from the left-hand side of t plus 3 over t squared minus 9. How about something like this? Well, we could, I guess we could simplify it. We could actually use a little bit of algebra here, but notice when I put 3 in here, I get 6. 3 plus 3 is 6. 6 over 0. 3 squared is 9. 9 minus 9 is 0. So I get 6 over 0. So we know that we're in this type here, type 3. Now we could simplify this because this is a difference of squares. This is t minus 3 times t plus 3. And then we could cancel the t plus 3's, but why don't we just try to do it like this? So if we're taking 3 from the left, so t would be to the left of 3, but close to 3. So maybe like t is about 2.99 or something. So the top is like 2.99 plus 3, so it's close to 6. The top is close to 6. And if I take a number like 2.99 and I square it, I get a number that's just a little bit smaller than 9. And so if I subtract 9 from that, I'm going to get a small negative number. So the bottom is a small negative number, and the top is a number close to 6. So I have like 6 divided by a small negative number. Well, that's a large negative number. So my answer is minus infinity. Okay? Let's just keep doing some more problems like this to practice. How about the limit as x goes to -1 from the left of x squared over x plus 1? How about something like that? Well, this time, when I put -1 into top and bottom, -1 squared is 1, and -1 plus 1 is 0. So we got like 1 over 0. So this is definitely type 3. So we can expect one of these as our answers, either infinity, minus infinity, or undefined. When I put -1 in there, when I do -1 from the left, maybe a number that's to the left of -1, but to the left of it would be like -1.01. -1.01 plus 1 is a small negative number. So on the bottom I have a small negative number. What about the top? Well, if I take a number close to -1 and square it, the answer is going to be close to 1, right? So on the top I have a number close to 1. On the bottom I have a number that's a small negative number. 1 divided by a small negative number is a large negative number. So the answer is minus infinity again. Good. So we're just going to keep doing some more questions on this, and then I think we'll be ready to move on after this video away from type 3 limits. What about something maybe a little bit more tricky? Maybe this one here, you might need to be familiar with the tangent graph. What about the limit as x goes to pi over 2 from the right of tan x? And what about the limit as x goes to the left of pi over 2 of tan x? Well, for this one, we kind of need to remember what the graph of tangent looks like, right? Do you remember that, for sine and cos, the domain of sine and cosine is all real numbers. But the domain of tangent, it's not all real numbers, is it? The graph of tangent, it kind of looks like this. At pi over 2 here, we have an asymptote. And then at minus pi over 2, we have an asymptote. And the graph, it kind of looks like this. It's like, and then it just keeps repeating, right? Forever on. Like that. So right now, if we're at pi over 2, and on the right-hand side of pi over 2, what are the y values close to there? Well, if I follow the x value and then go over the y value, see I'm way down here, right? And the closer I get to pi over 2 from the right-hand side, the closer this is getting to be minus infinity, right? So this is minus infinity. And now if I go on the right-hand side of pi over 2 now, then the values of the y values are over here, right? And the closer I get to pi over 2, the higher the y values get. So this one is going to be plus infinity. Alright, so those are some more examples there. Here we didn't really use that analysis of big number and small number and all that, so we do have to be aware that sometimes we really kind of need the graph to see what the limit is. Often for trig functions, that's the kind of situation that you have to do. How about something like this real quick? The limit as x goes to 0 from the right, or from the left, say, of, say, cosecant x. Well, that's the same as the limit as x going to 0 from the left of 1 over sine x, right? And if x is a small negative number, then sine x is also a small negative number, right? Remember the graph of sine, how that looks? Oh, it looks like that, sine x. So if x is a small negative, then y is also a small negative. And 1 over a small negative is a big negative. So this answer is minus infinity. So that's some examples with trig functions.